Bronsted acid base concept. That is the similar to Arrhenius acid base concept. Acid is the same. First point there is no solvent required. So first point is no solvent required. Here they are not talking about the solvent. First point is this one. Second, if you are talking about acid, gives H plus, gives H plus. This one.
There only what the thing is that if they are categorized as acid, then they are capable to give H plus, and base then able to take H plus.
So this is base is what
Sir,
takes H plus.
RNA shows that if it is acid, it will give H plus. If it is base, it will give OH minus.
Yes, correct. So this is point. Now, if I will tell you one more example. So if you see this one in the case of the HCl, so what it is going to give H plus plus Cl in the vapor phase itself. So it is giving H plus ion. So it is the Bronsted acid. Many things are the same. Bronsted acid, Arrhenius acid are the same. There is no difference in that. Now base. Base if talk about the NH3. NH3. So it is it can be accepting the low, H plus ion. It is having the lone pair electron. It can accept this one. So what is there? It is going to form NH4 plus. So this is what since it accepted the what? H plus ion. So it is the what base? This is Bronsted base. Bronsted base. Are you able to understand this? Many examples we can give. Here, suppose that is OH minus ion is there. It can accept the H plus. So what it is going to accepting means it is forming H2O. So this is again going to be Bronsted base. See, whatever the species which can accept the H plus ion, that is going to be Bronsted base, and that can give H plus ion, that is going to be the Bronsted acid. This is what the simple concept is there. Okay, first one. Let us move on the next slide. Reaction between they are saying reaction between Bronsted, this is their Bronsted base and Bronsted acid. Okay, if you are treating the Bronsted and Bronsted base acid, what it is going to Bronsted acid. So what it is going to give? It gives conjugate acid base pair. Conjugate acid base pair. What in case of Arrhenius you are getting between reaction between acid and base? What you are getting?
Salt and water.
Salt and water. But here you are not going to get salt and water. Even in the Lewis concept, you are not going to get the salt and water. In the Lewis concept, you are going to get the coordination compound. Now, suppose you are taking the H2O and another things you are taking the NH3. It is the Lewis base. I am supposed to. Otherwise, you can, here is the what we are taking. Here is the Lewis, not Lewis base. Yeah. What will be there? Bronsted base. And this we are considering Bronsted acid. Now, reversibly, what is going to happen? NH4 plus it will give NH4. And here is OH minus. So Bronsted acid is having the Bronsted base. It convert into Bronsted acid is having conjugate base. Conjugate base. And base is having what is there? Base is having conjugate acid. Conjugate acid. Conjugate acid. Now if you talk about the conjugate acid, how it is formed? Conjugate acid base plus H plus ion. If you are adding, so you will get the conjugate acid. If I will talk about conjugate base. So conjugate base means acid minus H plus ion. This is what the concept is. Can't you understand? I'm erasing this one. Can I write the conjugate base and acid pair. Acid, conjugate base and conjugate acid pair for following species. For following species. Following species. What are there? Here I am writing the species. Here is the conjugate base. CB means conjugate base. CA means conjugate acid. Okay, start. Here is the H2, NH3, HCO3 minus, HSO4 minus, C2H5OH, HNO3. Okay. Wait. Here you see. If you are writing the conjugate base, so acid minus H plus it will be there. Acid minus H plus. So you are writing correctly or what? Okay. Write down. So this what you are writing, that is absolutely wrong. Okay, correct. What will be conjugate acid? Okay, good. That is correct. What you are writing 2 here. Should I tell the others one?
Sir, yes, you to tell the last two.
But the conjugate base you are not writing, only you are writing the acid. Is it audible to you?
Yes, sir, audible.
Okay, thank you. See, in conjugate acid, what we write, that is base plus H plus. You add the whatever the species are there, you are adding the H plus. And here is whatever the species given, I am writing simply species minus H plus. Whatever species they have given minus H plus. And here is species. Whatever the species it is given, what you need to write. Okay, let me write here, rewrite. Conjugate acid. So whatever species is there, species. In the species you add the H plus. Conjugate acid base pair, what is there? Note. CB, conjugate base and conjugate acid only differ in what? Can you tell me? Only differ in H plus ion. Only differ in. So here H2O, that is correct. So what will be there? If you are adding the H2O plus H plus, what the species you are going to get? Tell me.
H2O2.
H2O2.
H3O plus.
H3O plus. So conjugate acid will be H3O plus. You added H plus. H2SO4. H2SO. What is there? No. C2H5. It is OH. A lone pair electron is there. You are adding the H plus. So what will happen? It is no C2H5 OH2 positive charge. This one. So this is, so here we are writing C2H5OH2. Here is positive charge. This is there in the 12th standard. This will come. Protonation of alcohol, protonated alcohol. HNO3. If you are talking about HNO3, here is lone pair electron is there. If you are adding H plus, it will accept the H plus. So H2NO3 positive charge. So here is it going to be H2NO3 positive charge. Conjugate base you are removing. So it will be what? One hydrogen you remove NH2 minus. Here is CO3 2 minus. Should I explain?
No.
Should I? Here is SO4 2 minus. Here is C2H5O minus. NO3 minus. Check whether you are able to or not.
Just one second. I will write this down.
Done.
No, no.
Can I erase?
Yes.
Okay. The next one is what we are having. Lewis acid base concept. This is Lewis acid base concept. Have you any idea about this one, Lewis acid base concept, Sanoy?
So which is electron deficient would be Lewis acid and which is electron rich will be the Lewis base.
Okay, wow, 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 very good. Lewis acid. They are lone pair acceptor. Lone pair acceptor. They are lone pair acceptor. Okay. This is what, like case 1. EG we are going case 1. Okay. Electrophile. Whatever the electrophile are there. So electrophile are Lewis acid. Lewis acid. Okay. Like CH3 plus is there. NO2 plus is there. Okay. H plus is there. Okay. Okay. Cl plus, whatever the positive charge you may write. Okay. It will be the, what will be? This is the Lewis acid except H3O plus. Why H3O plus is not Lewis acid? Can you explain? Can you explain?
It's 3O plus.
It has completed octet. It has completed octet. If anything is having completed octet, it cannot accept the lone pair electron. So if it is not able to accept the lone pair electron, so it will not be Lewis acid. Case 2. Incomplete octet. Incomplete octet. BH3. This one. AlCl3. FeCl3. They all are having the incomplete octet. How many electrons are there in the valence shell? Aluminium. Aluminium configuration 283 and 3 electrons shared with the chlorine. Total electron is 6 electron. Here is also vacant. Here is also 6 electrons. So if incomplete octet, they will be acting as a Lewis acid. Okay. Case up now. If I will write the Lewis base, what is going to be Lewis base? They are lone pair donor. Lone pair donor. They are lone pair donor. Okay. Example 1. Negatively charged species. Negatively charged species. If you talk about negatively charged species, what are the negatively charged species? Suppose it is Cl minus. Okay, Br minus, I minus, okay. Here H, okay. Okay, next one. Whatever the negative charge you can mention, they are capable to donate lone pair electron. Okay, so this is the Lewis base. Next one, example we are writing neutral molecule, neutral molecules with lone pair electron, LP electron. Like what example you can get? This is the example type 2. Like H2O. H2O is having lone pair electron. So it is going to be Lewis base. NH3. This is what? Lewis base. Anything you can write. PH3. Lewis base. Neutral molecules having lone pair electron, they are also capable to donate lone pair electrons. So they are going to be Lewis base. Can you understand this? Can I erase?
Yes.
Okay. Reaction between. Next point is there. Reaction between Lewis acid and Lewis base. What compound is going to form the student? Reaction between Lewis acid and Lewis base.
Coordinate compound.
Coordinate compound. Why the coordinate? How the coordinate compound will form?
How it will function? How I don't know.
But you need to explain, na? If anything is getting formed, that you need to explain. Okay. Lewis
Sir,
acid
for
base.
example, if H plus and Cl minus are combining, sir, then they will give HCl. So, sir, that way, the all the electron, that means that it is a coordinate compound. So, similarly, if they are being added, so they will give the coordinate compounds.
Suppose you are taking BH3 and another one is NH3. It donate lone pair electron to this one. It donating. So this is what is called coordinate compound. This is going to come coordinate compound. Coordinate compound are also salt. Coordinate compound. This is also salt only. Okay, double salt, your complex salt. Suppose if I will go boron. Boron is having number of valence electron. Do you know how many? How many valence electron is there in the boron? Huh?
Boron 5 means 2, 3 are there.
3 are there. Okay. So now if you see the octet of boron is not complete. Yes, yeah, no. Total electron
Yes.
is there 6. Now, what we are going to do here, NH3. NH3, if you are taking 1, 2, 3, 4, 5. Hydrogen we can mention here. This one. Hydrogen is having absolutely 1 electron. There is no doubt about it. Here you see nitrogen in case of ammonia, it is capable to, what it is capable? It is capable to complete the octet. Okay. But other is not completed octet. So what will happen? Ammonia molecules share both the electron to the, which one? BH3. So next one, since the both the electron is shared by the, which one? NH3 molecule. So this is what the bond is forming is the coordinate bond. Can you understand?
Yes.
Coordinate bond. This is it. Can I reach? Can I reach?
One second. So you can erase now.
Okay. How can you say, how can you say AlCl3 is Lewis acid? How can you say? This is question for you.
Thirteen. So ALC. One second. LCL3 means So here L will be there, phase balance with 3.
Hmm. That is outside of the CL, it will be circle will be there. Inside CL, where the CL octet completing, how the dot structure
Oh,
you are.
sorry, sir, one second, sir. I'm drawing one second.
No
Here.
problem, no problem. I can understand that. You just no need to give this much, just little bit information. If you are giving, that is more than enough. Okay, okay. Means total electron is how many you are saying? 6 electron. Okay, good, good, good. Hmm. Thank you. But your diagram is not correct till now. Okay, this one. Next one, you heading last class I told you I will teach you gives free energy. But meanwhile, time gone. Gives free energy. We did not do this one. Yes. Problem also we didn't do this one. Gives free energy. So what how definition is there? It is maximum amount of energy. Maximum amount of energy. Amount of energy. Energy which is utilized in it is utilized in doing useful work. It is maximum amount of energy which is used in utilize you doing useful work. Can you understand this?